to do the after assay to confirm that it relate with the migration. We to do the invasion assay by Tanwells, and we can find that the cell that have the BAP2L1 can invade. We have the membrane, and they can invade from one side to the another side. So they have the characteristic of the invasion. And so when I prove that the BAP2L1 is the can relate with the migration, so I review in the step by step of the cancer migration or metastasis. We found that they have the many steps when cancer cell will be moved to the another side. No? This is the primary site in the first time. You have the cancer, no, in stage 1 or something like that. It is the bulk of tumor in one side, and you have the epithelial cell in the buccal, in the bulk of the tumor, and this cell, epithelial cell, will move. Before they move to the another side, they will change from the epithelial cell to the mesenchymal cell, and then go to in your bus and go through in your body and go out the blood from the new site that they want, such in lung or in liver or something like that. And we found that it is important if the epithelial cell to start become to the mesenchymal cell. If we can find some mechanism, and maybe we can stop the migration of the cancer cell too. So we review in the cancer cell migration. When the cancer you see in this, in the epithelial cell in the border will to move to the another, they will start to the survey around the area that they in the cell like this. When the border of cell of the border to survey around the environment that they will move, they will have in the frontal border and the real border. In frontal border, they will have the something in the like the microneedle we call the philopodia to the survey the environment, and then they okay and they will move in that direction. And in the philopodia like that, they have the many the group of protein that control the when they want to the movement, and we found the importance of the protein that important about is say the coffin, because this coffin is the protein that control the movement. If they want to stop, coffin it will active, and if they want to the movement, to create or produce the filament, the coffin will change to the phosphocofilin to the inactive form. So the filament or actin polymerization will to be continue to longer. And this is the step that we can, this from the review article, we found that the coffin is important to they can produce the actin polymerization and to produce the philopodia to cancer can migration. And so I to draw the picture to like to easy to understand. No? If they have they want to stop to the movement, the coffin is active, and the actin will degrade to actin monomer, and delete F-actin or philopodia and stop the migration. But the covalin is in the inactive in phosphocovalin. It will have still, the increase the actin polymerization and philopodia will increase and cell will migration. So I want to improve this concept. So I to do the immunoparticipation. By we found that 40 protein that in the top 40 protein and some protein relate with the migration protein such as aldo A and covalin or TPM1 like that. And so I prove it by the use the Western blot to improve the expression, and we found that if you have more biax-2L1, we will have more covalin and more aldo A too. And we confirm that if we have the more biax-2L1, we will have more filament. You can see the filament like this in the micro needle like this. If you can see that if you have the more biax-2L1, you will more the I call the philopodia or use the protein F-actin to detect it and more in the overexpression of biax-2L1 and the localization of the position of the F-actin will be in the cortisol. It the near cortex, not near the nucleus. When if one cell when the cell want to migration, the F-actin protein will be produced around the border of the cell or the cortex. And if we knock down the biax-2L1, the F-actin or philopodia will decrease. And in the same, the expression of the F-actin in the cell will decrease too. And we confirm the mechanism of covalin and phosphocovalin by Western blot, and I confirm it, and we found when the cell migration, the expression of the phosphocovalin will be increased when we have the more biax-2L1. Another is, okay, I will script in this. And so in my thesis or in my research, we can conclusion that when we have the over biax-2L1, it increase phosphocovalin expression in the spatial localization, and they can to have the more F-actin and to increase the philopodia and to make the promote cancer migration. This is from my thesis. My paper is published in 2022. And this is only the first step to find the basic side of the mechanism of biax-2L1 that important for the cancer cell migration. And if you want to find the new target or the new drug discovery, you must do more explore in the in vivo experimental, such as in the rat or in the mouse, and someone wonder it's important in the patient or it's important only in the experiments. So we use the data of the patient in the base cancer patient to do the expression of the biax-2L1 gene, and we found that the patient have the breast cancer and have metastatic. It have more biax-2L1 expression than the patient have only primary tumor. And when we to do in the subgroup of the type of the breast cancer patient, we found that in HER2 positive type, by F2L1 expression, I mean the in patient with metastasis is significantly like in the second picture. So it can tell you that biapterone is important in vitro experiment and in the patient too. So it may be through the potential target that they may be interested into find the new drug discovery. And this is my the research. And this thank you acknowledgement in my laboratory team when I learned in the PhD in Siriraj Hospital, Mahidol University. This is my team. And thank you to the Burapha University to give me opportunity to learn PhD students. Okay, thank you.
Okay, thank you very much, Dr. Nat. Please be seated again. Thank you very much for your excellent and insightful presentation. The discussion on cancer cell molecular mechanism. Speaker, there is questionnaire that students should be filling in the form. Okay, I'm sorry, I will speak in bahasa. Jadi pada teman-teman peserta seminar bisa scan QR code. Ya, tolong diisi untuk kuesioner pembicara pertama ya. Sudah? Sampun? Sampun. Okay. For the second speaker, we will have our distinguished speaker. This is Dr. Hamzah Al-Khatib from University Kuala Lumpur, Royal College of Medicine, Perak, Malaysia. Let me read the CV briefly. Dr. Hamzah Al-Khatib, the permanent address in Kuala Lumpur, Malaysia, but his nationality is Syrian, and you can speak Arabic and English. Assalamualaikum, Dr. Hamzah. I only can say Assalamualaikum. Okay. For the academic qualification, Dr. Hamzah graduate from PhD in Pharmacy, Pharmaceutical Technology on 2022 from International Islamic University Malaysia, Kuantan, Pahang, Malaysia. And then for Master, he graduated from Master in Pharmaceutical Science, also from the same university in 2018. And for the Bachelor in Food Engineering Technologies in 2015, Aleppo, Syria, Faculty of Technological Engineering. Okay. For work and experience, he is a senior lecturer from June 2025 until present in the Faculty of Pharmacy and Health Science, UNIKL RCMP. Yeah. Before he was work in University College of MAIWP.
Mawib.
I'm sorry?
The name is Mawib.
Mawib. Also in Malaysia.
Malaysia.
Okay, so you moved from one university to another university in
First start at UCMI, University College Mawib, for 3 years. Then I moved to UNIKL like relatively recently.
Okay. Okay, and he He was a head of pharmaceutical technology department in MyWeb.
Yeah. Yes, exactly.
Okay, and also he had the appearance in research officer, pharmaceutical industry, R&D, quality control. Yeah, a lot of experience you have. Okay, a lot of conference. I will not read everything because this is too long. Okay, anyway, ladies and gentlemen, please welcome Dr. Hamzah Al-Khatib. You will have 45 minutes for presentation. Please, the time is yours.
Okay. Okay, assalamu alaikum. Good morning. Actually, first of all, I would like to thank the management of the university for the invitation, and also the dean for the invitation, and also the complete team because during the arrangement they did a lot of work to achieve this conference. And thank you so much for this invitation.
The slide, please.
That's okay. You can see it.
Yeah, please wait a moment. Do you have the pointer? Yeah.
Okay, so while we are waiting for them to prepare the slides, so as I can see here that like the majority of the audience, they are students. So here it is actually something important. And also for Dr. here, she already mentioned about like it's okay to not really fully understand what we are saying because like in English and the teaching here in Bahasa, Indonesia. So it's fine. So, but for sure, you will capture a few things. It will give you like you can the first step like to know new technologies, to learn more, to get ideas. So it's fine. So just enjoy the time and get as you can knowledge. Okay. All right. Okay. So my name is Hamza Khatib. I am Syrian, but working in Malaysia. Is almost about 10 years in Malaysia. I start my study there to start like my postgraduate studies for master, PhD, as we mentioned in International Islamic University Malaysia. Then after that, I start working in the academic and also as a research officer in the industry. Actually, it was during my PhD. The project, it was in industry. At the same time, my PhD topic. So hopefully we can share some what we got. Okay, so our topic is optimization of a critical electrospray parameters for ion exhalation-based microencapsulation. Okay, so basically, as we mentioned, that we have microencapsulation, we have ion exhalation, microencapsulation, and electrospray by the aid of electrospray. So this is why we are going to focus about these four topics. We are going to cover the main topics. First of all, introduction to microencapsulation, to understand what is microencapsulation, why we need microencapsulation in our study in dosage form design. And then after that, after we understand microencapsulation, we are going to cover about ion exhalation, the method of ion exhalation as part of microencapsulation. Later on, we have to cover about electrospray parameters, or to understand electrospray as technology or technique to be used to control the size of particles, the produced particles. Then after we understand the electrospray as technology, we can move to the optimization of parameters. Okay. So first of all, we have to understand what is microencapsulation. For microencapsulation, to have particles as the product of microencapsulation, we have to understand microencapsulation contains two materials. This is the basic, the main two materials, which is the wall material. Then we have the encapsulant. The encapsulant, the material that we are going to encapsulate. Of course, we can have other materials or excipients can be added based on the function of the material itself. Could have stabilizers, we could have emulsifying agents, could have. But for sure, we have two main materials. These materials, the wall material and also the API or the active ingredient that we want to encapsulate. So always we have to know that when we make particles, there is a challenge to achieve size below 1 millimeter. 1 millimeter, which equals to 1,000 micrometers. So always there is a challenge to achieve that size. By normal technology to make particles, solid particles, to be produced below that size, there's a challenge. It's not like by milling, like we have like granules, for example. We have granules. These granules, to be produced, to make it like fine or powders, we can have milling. So this is something else. We are talking about microencapsulation. As microencapsulation, to achieve this size as complete particle and this particle, and why it's important to be as complete particle as the product? Because one of the aim of these particles, like we could have control release. So that means we have to have it as complete system, not modified, not milling, not damaged. So it should be that. So this is a challenge to achieve that size. We have to have technology, which could be one of the methods for microencapsulation. Later on, we will see the methods for microencapsulation. By the way, to produce microparticles by few methods here could be the same method. We can follow the same method also to produce nanoparticles. But we have to modify some parameters. Like we have to control the parameters of manufacturing or fabrication. We have to control the parameters, then we could achieve the nano. Of course, it's not that easy to achieve nano size, but as technology, to understand it, we could have the same method could be used or followed. Okay, so based on the method that we follow, as I mentioned, that we could have different methods to prepare nanoparticles or different technologies to prepare micro or nanoparticles. Based on the method, we could have or we could produce two types of micro or nanoparticles. Two types. The first one, nano or micro capsule, and the another type, which is the nanospheres. What is the difference between nano or micro capsule and spheres? For capsules to be produced, that means we have the wall material, the wall which is encapsulating, is surrounding the encapsulant or the material we want to encapsulate. Is surrounding it. Could be lipophilic, could be hydrophilic material, could be oil soluble, could be. And also, as advanced drug delivery, we could have nanocapsule encapsulating at micro size or even bead size, like beads could be 1 millimeter or 1.5 millimeter or even 2 millimeter, could be done, and inside it we have nanoparticles as system. So this type of system we can follow, we can achieve, we can control release. So because we have here two conditions, or two, the first one, the first layer, which is the wall material. Then the next we have the small nanoparticles which already encapsulated inside the micro or large or macro particles. So the first step, we have the release from the wall material. Then after that, what is the material that already released is the nano or the fine particles. These nanoparticles by itself is going to be or to give release later on. So this is why we could have sustained release or controlled release. So the other type, the nanospheres. So the nanospheres, the encapsulant or the material we want to encapsulate is going to be distributed among the encapsulating material or the wall material in matrix. So everywhere we can see the encapsulant is distributed among all the encapsulating material or the polymer. It's going to be among everywhere, distributed everywhere. Even at the wall, we can see also if we will test it, we can see that there is API. API is active pharmaceutical ingredient or the agent that we want to, we are working on it. So it could be everywhere, distributed among matrix. For this matrix, so why we have these two types? It's based on the technology, yes, and also for us when we decide, okay, I want it to be as capsule or I want it to be as spheres. So this based on the technology. So by having these spheres, it could be as system, and this system is can have controlled release and no. But at the same time, for nanocapsules, actually, it's already have advantage compared to nanospheres. What is the advantage? For example, for taste masking, taste to hide the taste of pharmaceutical ingredients. So to hide the taste. Why? Because the wall material is already the wall material is already encapsulating completely the active ingredient. Why? For spheres, it's already distributed among all the material. So, so now we have to know why we need microencapsulation. Microencapsulation could improve stability, could have taste masking, could have controlled release systems. So by all that, we can achieve it by encapsulating or by microencapsulation. Okay, so before we move to ionic gelation, so we have to understand that, or have to know, we have different methods for microencapsulation. Different methods for microencapsulation. So we have traditional or like the famous methods. We have solvent evaporation. We have supercritical fluid methods. We have microfluidic technology. We have spray drying, and also we have electro spraying. We are going to cover about electro spraying after that. So just to explain a little bit about some methods, or maybe we can cover only the first method, which is the solvent evaporation method. So we can cover about it to understand like how we could have solid particles. For solvent evaporation method, actually is depending on the emulsification. First of all, we have organic solvent. Organic solvent is not soluble in water, this solvent. So organic solvent has the ability to encapsulate, has the ability to dissolve polymer. The polymer here is going to work as wall material later on. So it will be dissolved first, so it becomes as liquid. This liquid is going to be emulsified with water phase. After emulsification, is going once we mention emulsion, that means we have small droplets. So these droplets, we have evaporation method. After evaporation, what will left behind? The evaporation for the organic solvent will left behind the solid material, which is the polymer material. After the solvent evaporated, that means the polymer become not soluble in water, so it becomes solid. So by this step, we are going to have the small solid particles. So based on the process parameters, we could achieve micro size or even nano size. For example, what parameters we could have in the first method, solvent evaporation? We have the homogenization speed, because we have emulsification, correct? For emulsification, we have to homogenize using mechanical tool, homogenizer, or even ultrasonic homogenization step. So by using the power, increasing the power, we could get smaller droplets, then later on smaller particles, and also homogenization time. The time also is important here, and also the concentration of a stabilizer. We have the concentration of polymer, so it has optimization by itself, but we can just understand that by controlling the parameters, we could achieve the wanted or the required size. And also, why? Who can decide the size? When I want it to be microparticles, when I want to be nanoparticles, actually is based on the design. I want to design it to be at that size. So based on that, we can play and control the parameters. So here we can see that we are using, like, there is organic solvent used. Organic solvent basically is also not safe to be there. Should be, we have to make sure it's completely dissolved, evaporated, and is not there. So this could be one of the limitations to be used. And also we have the other methods. It's also based on the emulsification, and then after that evaporation of the solvent. Then after that we have the polymer. Okay. So now we already covered about microencapsulation in general, why we need microencapsulation, and we saw that we have different methods of microencapsulation. Among that method, we have ionic gelation. Ionic gelation, I'm going to cover about one of the polymer can follow the ionic gelation as example, which is sodium alginate. Sodium alginate is a polysaccharide polymer, is water soluble, which is important to be water soluble, but is easy to dissolve and to deal with. This sodium alginate widely used for many applications in food, industries, biotechnology, engineering, and also in pharmaceutical applications. Before moving there, so for sodium alginate actually is already sourced from the brown seaweeds or from bacteria. First, of course, this out of my specialization, that to be extracted and to get the sodium alginate as polymer. Then after that, from the polymer, we can make ionic gelation as particles or even beads. Okay, so for sodium alginate, actually it can have the ionic gelation by the presence of calcium ions. Calcium ions. So this is why we call it ionic gelation. We got the gelation. So calcium ions is positive ions, and can make connection between the COOH, which is negative. So when it already can connect to side, then the chains will get cross-linked. Cross-linked, they get the gelation, so it get to be solid. And the feature of it is non-toxic, and also the biocompatibility, biodegradability of the polymer itself, which is very important as polymer to be used or be selected in pharmaceutical dosage form. So to be biocompatible and biodegradable. And also it's can cause water-insoluble gelation. Water-insoluble gelation, which could be as suspension later on and can be worked. And if you still remember, it can be is from polysaccharide, water-soluble polymer. By the presence of calcium ions, become water-insoluble gelation steps. Okay, so now we have just to cover a little bit about the process here, like how we can have the particles, how we have the particles. For the particles, first of all, we have to have the mixture of the polymer Could be emulsion, could be mixture, could be solution to be used or follow. This, we have the first step. Actually, this one is as example of my study, of my work, so we can explain it in general here to understand the concept. So we have the step of emulsification or mixing. This and is very important step. Why is very important step? To get homogenized formulation. For mixing or homogenization, is very important to get homogenized formulation. Later on, to control those, so it should be homogenized. So after that, we can drop it one by one as droplet in calcium chloride solution. Calcium chloride solution could have, can cause the ionic gelation. So then we can get particles or beads, as you can see at that side. So how to control this particle is about the size is about 1 millimeter. We can control it to make it smaller by using the electrospray. So now we know we saw that we have like different methods. So what is the method? How to select the method? Is for me, I'm a researcher, for example, or any students, they are doing research. So it's like how you decide which method I have to follow. So in general, we have to, the method can give me high drug loading, could be one of the important, and also homogenized size distribution of the particles. So once this method can give me these features, it could be suitable. And also we have to understand something here about, and should be simple to operate. What means should be simple to operate? For us as researcher, and this point I think is important for the students, especially who is going to to go more to research. Simple to operate doesn't mean that it's easy to operate. No, it's simple to operate. That means it can be scaled up, because at lab scale we can do whatever we want. We can use organic solvents, we can use toxic solvents, we can use whatever we can use. Then later on, we have to find method like how to evaporate, how to remove the solvents there. So, but is it really, can we scale up the method at the larger scale? Because like to be as a product later on. So this is why it should be simple to operate. That means it can be scaled up. So we have to carefully choose the method, by steps, clear steps. These steps can be, like for example, homogenization, yes, can be scaled up. For mixing, yes, can be scaled up. Using solvents that is safe to use, yes, can be scaled up. And also we have to mention, when you are doing lab work at research, try to use pump. Try to use pump for like to transfer things from one step to another step. Why to use pump? Because you are already controlling the process. You are controlling the process. Once you control the process, it's already easy to scale up later on. But if you are mixing using the magnetic stirrer or using whatever the method, which is okay, now it's already homogenized. Later on, I don't know, is going to be homogenized or not. Or maybe different person that going to repeat your method but will not get the same results. So this is why it's like we can use pump. And this idea was from my supervisor. He advised me this during my PhD. So it's like you have to choose like steps, can be easily scaled up. Then you are safe at the lab scale, and also if there is potential for that product to be scaled up, so you can move up to large scale. So now, as I mentioned, we can produce beads or particles by ionic gelation using sodium alginate, but the size relatively large. It could be like 1 millimeter, 1.5 millimeter, but we want to achieve the micro size or even nano size. We can use the electrospray. Electrospray is one of the methods that classified under the electrohydrodynamic, which is the process of fluid dynamics under the effect or the impact of electrical fields. So to affect the size. So among the electrohydrodynamic, we have electrospraying and we have electrospinning. But for us, we're going to cover electrospraying only. For electrospinning is more to have tissues, biological tissues or film can be produced. But for us, we are going to cover only the particles or solid particles. Okay, so we have to understand also the principle of electrospray. For as setup, this one could be as the lab scale. The setup is first of all is going to be to have like pump or syringe pump or even peristaltic pump. Then we have needle. So the pumping of the formulation is going to be through needle into calcium chloride bath or collector, is fluid collector, could be used there. Okay, the main element is the high voltage generator. High voltage generator to provide the volt, the high volt. The high volt means could be 5,000 volt, could be 7,000. To achieve nano, we could reach to 10,000 or 12,000 volt. So the principle, first of all, by increasing the high voltage, the flow is still same, but that droplet is going to be smaller and faster. We increase, then until we reach the conject. The conject at that critical point, which is we reach the high volt suitable for jet, then we have the spray. Once we reach the spray itself, that means we already start to have the very small particles, could be microparticles, could be even nanoparticles to achieve. But again, it's not that easy to achieve the nanoparticles. Why I always am mentioning it's not that easy to achieve it? Because it's not only that I have to achieve the size. No, I have to achieve uniform size. We have to achieve the uniform size. The size distribution should be uniform among the formulation. So, so this is the principle of the electrospraying. So after we know the principle, so we have to know what the parameters for electrospray. Once we know the parameters, then we can understand the optimization. So we have to understand the parameters, what the critical parameters, then later on we go for optimization. So this is why for the parameters usually for electrospraying is the flow rate, is one of the most important parameter is the flow rate. Why is important the flow rate? Because when we reduce the flow rate, we get smaller size. So this is why to achieve very small size, we have to go very small flow rate. Why? Because the small or the low flow rate, we can give enough time for the droplet to get the high volt, the effect of high volt, because the flow is slow. So I'm giving time for the volt to influence the droplet, then later on to become smaller or even to achieve the spray. Then we have another parameters, which is the size of needle. Like, of course, smaller size of needle will give smaller droplet. Then this smaller droplet, it will have larger, will be impacted by the volt, the high voltage value. Also, we have important, the second important parameter is the high voltage value. This is the main parameter can influence because the high voltage, once we reduce the high voltage value, we can achieve the very small or even the spray droplets. Then we have another parameter, which is the dripping distance. The dripping distance between the needle and the surface of ionic gelation surface. The needle, between the needle and the ionic gelation surface, this is the dripping distance, because smaller distance, of course, is going to have a stronger electrical field. But once I make it, make the distance already like longer, that means I reduce the effect of electrical field. So these the parameters that we have to know about الكترو spray. So then later on we can see the. So here I will give example of the optimization. Before I go through the optimization here, okay, so we have for optimization in pharmaceutical formulation or dosage form, or any optimization, but for us we are focusing here about the pharmaceutical dosage forms. So optimization, we have to do screening first. We have to do screening first to know what the parameters that could affect, has influence or has impact. So we have to do the screening first. Not all parameters could have the effect. So this is why we have to do screening first to see the effect. Then later on, we can go to the next step to have the optimized parameters. So how to decide? How to decide the parameters for screening? We could have so many. Maybe someone will say that, oh, okay, I want to take the light as a parameter. I want to study the effect of light. Or I want to study the effect of my colleague in the lab, is he noisy or not. So I have to, so what parameters that I have to select is not, so it's based on experience. Because when someone is doing the work in field, he already has experience, so he knows what to select, what parameters to select. So he should both select parameters which we can call it independent variables. Independent variables that it could cause the effect. Then we have to, the screening usually for optimization, screening usually will be done for 2 levels. So here for me, I already done it in factorial design. 2 to the power 4 of factorial design. Why is factorial design? That means I have 4 independent variables and also 2 levels. So for screening, we have to choose 2 levels: high value of the level and low. So how to decide the high and low? Also is based on experience and based on the range of when I want to study. Okay. So this example, what we have example here is for encapsulating of black seed oil, habbat soda oil in alginate beads. So I want, so this is why based on the experience we can know what is the levels, how to select the low, how to select the high. So based on the experience also we have to choose alginate concentration. So alginate concentration to give me material with good encapsulating or lodging encapsulating, the concentration of alginate as low we can choose 1. Below 1 is going to be difficult. Why? Because it's not going to have that strong encapsulation. So no need to study that one, because for me, I'm going to have as a product at the end. So this is why I have to be logic. So no need to go lower than 1. So 1 as low, yes, can be selected. So I selected the low at 1. Then for the high, 2% is enough. Why 2% is enough? Because if I will go, because we already done experiments, so we know. If we go more than 2%, that means the alginate, sodium alginate is going to be so viscous, and the high viscosity will not allow to have smooth droplet, drop by drop. So this is why the range between 1 and 2 is enough to study it. Now I will not repeat about the value of the other parameters. Is based following the same principle we can follow. So the other factor is flow rate. Then we have high voltage value and the distance. Okay. So how to evaluate these parameters? I have to select what we can call dependent variables, which is depend on the factor first. For encapsulation, the size is important. The sphericity, the shape of the particles is important, and also encapsulation efficiency is important. So to know what is the drug loading in my formulation. So this is why we select these. So we have to check each variable, what is the result of size, shape, or sphericity, or encapsulation efficiency. After we done the screening, we done the result, then we can get the results here. So from the results, we can see that some factors is already has a significant effect, and some will have no significant effect. So once we have the cross, that means there is significant effect. But while we have the straight line, here in this case, we don't have a significant effect, or we could have a little bit effect, but it's not that significant. So based on also your experience and the results, the real results, you can choose that. So how to exactly choose after we've done the screening? We have something is called the interaction effect. Interaction effect. So within this interaction effect, we can choose. For example, here we have alginate concentration, and we have also the distance. So once I choose the alginate concentration at 2, once at 2%, then I can see there is no significant effect for distance. So I'm allowed to use, or I can use the alginate concentration at 2, because also can give me high encapsulation efficiency, and then I can use it because it will avoid the effect of the also the alginate concentration. Once we use the alginate concentration at 2%, then there is no significant effect of high voltage on the encapsulation efficiency, meaning that whatever the high voltage value at 2%, we have high encapsulation efficiency. So in this case, by using the interaction effect, we can choose what is the effect, what is the parameters to be used. After we done the screening, we can, you have to know that we can move to the response surface design. Response surface design for the significant factors. In general, for significant factors, that we already choose it, we already done. So the significant factors for us here, that it has a real effect, whatever the other variables, it still has the effect, high voltage and flow rate on the size. So there is a change. So then we can see the behavior. Based on the behavior, based on the need, the size that I want to achieve, then we can select and we can get the regression equation, as you can see here down. And also another response surface design can be done for the sphericity to be done. After we done the response surface design and we done the analysis using the software, we can see what the significant factors. Then we can get the equation and we see the model. Is it significant or not significant? Once it's significant, then can be used for optimization. Can be used for optimization. Okay. So now I already explained in general about optimization, how the steps of optimization, how we can, of course, we can explain more and more, but maybe there is not that time to explain about it. It needs like maybe more than one lecture to do it, to explain about it. So, but here I would like to share about how we can scale up, ionic gelation method, how to be as large scale. It can be scaled up. First of all, let's ignore about the Elkett-Spray value. Let's ignore about it. Let's just focus about the ionic gelation itself. So how to scale up the ionic gelation? We can scale up, that means I need to use more than one needle, like multi needles at the same time. So this why we can done 3D printing multi needles to make sure that distribution of liquid is equal among each needle. So in this case, by one step, I already increase the flow rate using one step. Flow rate already increased from, for example, here I have 12 needles. So the flow rate increased from 2 ml per minute up to 24 ml per minute. Is by one step. So this is why here how we can increase, and by the way, we already done it at large scale, but without Elkett-Spray. So once we have multi-nozzles, we have it. So we have two issues. The first issue, the connection. Because for high voltage, we can connect the high voltage to one needle. But here, we have multi-needles. Like we have, in our model here, we have 12 needles. So how to connect the high voltage? Is it like I have to connect each needle by the high volt generator? No, no need for that. We can connect it by using one high voltage generator. And also we have another issue for large scale, which is the dripping distance. For dripping distance, because I'm talking about large scale, once we, that means the volume that already dropped in the tank, mixing tank, is going to be large in very short time. Because it's large scale, we have like fast production, so it will be increased. Once it's already increased, that means I'm going to affect the distance between the needle and the surface. Why? Because I put a lot of particles here in the calcium chloride path. So how to control it? Maybe we can use ring. We can use ring at fixed distance. So whatever the volume here is okay, no problem. Because I make the distance is fixed between the needles and the negative charge electrode. So now another challenge is the connection. So usually in electricity, maybe in pharmacy students, they are not like so good in electricity. Also, I'm not so good in electricity, but this is the principle there. So we have parallel connection and we have series connection. So for me, when I start my experiments, I use the series connection. Why? Because I'm not so good in electrical studies, so I'm not so good there. So I use the series connection. Then I searched a little bit, then I found that for series connection, the volt is going to be distributed among each needle, meaning that the value of volt for each needle is not going to be uniform, it's not going to be same. But if we have parallel connection, that means each needle is going to have the same source volt value. So this why it's like can be used. So this we can follow this one, and we have to connect the multi nozzles. So for example, this result is already published. Here we have no application of volt. We have multi-nozzle. Multi-nozzle, we produce the particles. This one, large particles, not like microparticles. Large particles is about 1.5 millimeter. So if you can see, that is uniform size and spherical particles. But when I apply 6 kilovolts, 6,000 volts by series connection, as you can see, the particles actually it doesn't have uniform size. Some small, some large. So why? Because the value of volt is not same at each needle. It's already distributed, so other factors could affect. So this is why the series connection is not that, and also the distance between each needle to another one could affect the production. So here I have result is not published anywhere. This is just we start like a project, small project with my supervisor. Actually, it's his project, but I just help him after I graduate my PhD, so I work with him. So just as acknowledgement for him, is not my results. It's my results, but his project. So, okay. So here, what I done, parallel connection, which is the source of volt is one source. It's already give the same value of volt for each needle. So we can see the difference. There is difference. We can see application of voltage at 5 kilovolt, parallel connection. This is the size. And you can, the most important, the spherical shape. So it's already here. But when I increase the volt to 10,000 or 10 kilovolt, see how the effect is become smaller, but still almost spherical. That means the parallel connection is working very well. So we have to continue the project later on to make verification, to make the study, to get more like confirmed result about that. And to be used for large scale, because we done large scale, but without electrospray. Electrospray could be used later on for in the future. Okay, so here how this one, as I mentioned, this result is not mentioned anywhere. So we have the mixture of the emulsion. This formulation is about black seed oil, habat sauda, to be encapsulated. We have blisterling balm, and it's already connected to multi-nozzle. Multi-nozzle is the up, the white one. So then we have to distribute the multi-nozzle with equal distance between each needle. We cannot make it like randomly. It should be, why? To avoid the effect of distance. So we have to avoid the effect of distance to make the effect only the high voltage. So, and the Elkitro, the volt is already, this is the high voltage generator. High voltage generator should produce only volt without ampere. Once you have ampere, that means you're already done. So you shouldn't use ampere. It can produce only volt. Ampere should be 0. So this in later if you are interested to work on that. So this high voltage generator will provide only volt. The high volt is like thousands. It's already connected and already distributed by parallel connection for each, I'm not sure if it's clear or not, for each needle. Then we got the result that I shared just now before. Okay, so here also I would like to share about the large scale production. That this is why this project it was done in UIA, International Islamic University, Malaysia, during my PhD. Sorry. So in ICOB is the manufacturer GMP under the university. So the university itself, they have a GMP manufacturing plant. So it can be used. So actually they are like, it's a good idea to have it in the universities. So we done it at the GMP. Okay, so this project is using ionic gelation. We done all the optimization. By the way, also for the ionic gelation itself, it has optimization. It's not only the process of electrospray. The gelation itself, this I'm working on it in my projects now for my FYB students. So we done the large scale for black seed oil, habat sauda oil encapsulated in alginate beads. We done it at large scale, about 50 liters. We done it. So the steps of ionic gelation, I will explain it in short time. So first of all, as I mentioned, we have the homogenization step or mixing step, which in our, because we have oil and we have alginate solution, so we have to have emulsification step. So first of all, we have to dissolve the raw materials. Raw materials can be dissolved here. Then after that, can be dissolved and make the initial emulsion, but is not so homogenized. Then after that, we have the sonication as emulsification step is going to be done. Later on is going to be in holding tank. Holding tank is going to pump the emulsion using multi-nozzle in the curing bath. Curing bath, it has the ions, calcium ions there. After the curing there, we have the filtration step and washing and filtration. It can be done there. Then later on, we got the black seed oil alginate beads as solid particles already encapsulated at large scale. In lab, we can produce like in very small beaker. We have a few beads, few particles. We done the analysis. We get the result. We analyze the result. We publish it. So, but here is already more or closer to commercialization, but still not commercialized. So we just like done the study and we stop at that. But inshallah, we are going to work more on it. So here that you can see the particles or the beads at larger scale is already produced, homogenized beads. Each bead is the same size. It's for test masking of black seed oil. And this the beads or the particles after drying to remove the water. Then we can have it here. Okay, here another project with my FYB students, propolis encapsulation. We done it. This one is still not published. the result not published. Maybe will work soon for publication. We have the 3D printed multi-nozzle to can be used, and we have the emulsification. This is the setup. This is why I'm saying that even in lab, you can use pump. Why? To control the flow rate, to control the parameters. Once you control it, you can scale up it. You have just, because you already know the parameters. So we have the mixture, propolis alginate. Then after that, we have the 3D printed multi-nozzle. Each nozzle, it has the same diameter. They have the cross-linking here with calcium ions. Then we got the particles or the beads, as you can see there, and with analysis, MSG analysis for the particles to see it there. So this, like as example, we done it after the students they finish their work. Still working with another students to continue the project, as the particles can be consumed. It's safe because it's only propolis and alginate. Alginate is food grade material, pharmaceutical material, natural product, so it can be used and is safe. There is only alginate and propolis. Can be produced, can be consumed as the rubber particles, or could be as after drying can be used there. So because propolis, the taste is very strong, bitter taste. I'm not sure if you already try it. It's very, very strong taste. By encapsulating, we reduce the majority of the taste. So once you can take the beads or the particles, you can easily consume it for children, for all people, elderly, because they have difficulties to get soft gelatin capsules, large capsules. So here you can just mix with food, with drink, with milk, then it can be produced and can be easily consumed. I think this is the last one, but yeah, this is some publication that about our topics. Our topics already published before. This before I joined UNIKL, but it's the same topic about optimization, encapsulation, ionization, and also for taste masking using the same methods. And recently, the pilot scale manufacturing is already published. And also, we have the recent advances in electrospraying and electrospinning technologies is already. It's all is my project. Not my. I mean, I'm the first author. So it's like with my team. Okay, that's all for my talk today.
Okay, please give a warm applause for Dr. Hamze.
Is there any question, or I can speak first?
Please sit down first. Okay, thank you very much, Doctor, for the informative and well-deserved presentation. The discussion on microencapsulation technology have given us valuable insight into the pharmaceutical innovation. Okay, please for the participant also fill another link, for the review to Dr. Hamze. Everybody is done? Okay. Okay, enough? Yeah. Okay, let's move to the next session. It's a panel discussion. Ladies and gentlemen, we will now move to the first panel discussion session for about 40 minutes. Yeah. We are honored to have both of our speakers on stage, and this is a great opportunity to deepen our understanding through discussion. I would like to invite participants to take part in the discussion. This is an opportunity to all of our students to engage directly with our esteemed speakers. Please feel free to ask any question either in Bahasa or in English. If you have a question, please raise your hand and kindly mention your name and institution. Okay. Also, the most important thing here, committee will provide a lot of door prize here. So for all of the students, please don't worry to ask any question for the speakers. Okay? Is there any question? Yeah, a lot of questions. Okay. Please give one there. First, we will open three question first, yeah, and then speaker will answer. And if we have time, we will start with the second session. Okay. The first question from the set. Yeah.
Good
Okay.
morning, everyone. My name is Yuda Rizky Nuari. Selamat pagi, Pak Is. Saya datang untuk ikut poster. Okay. Okay, so first of all, I would like to say that the presentation was very clear and also very insightful. And then I have two questions, actually. Of course, one question each. For the first one, and I'm not student, actually. So basically, especially for the material or for the topic from Mr. Hamze, I actually follow the research as well, because my research project or our research team also work with that kind of micro encapsulation. And then first of all, I would like to ask Mrs. Nut or Dr. Nut, right? Your name. So at the end of your presentation, you said you said that the gene, I actually can't remember the name because it's very long. The gene, you said that the gene is highly associated with the migration in breast cancer. But then maybe I didn't follow your last discussion or something like that. But then maybe you can elaborate more about hypothesis with regard to why the gene itself closely related to the migration in breast cancer. That's the first question. And then for Mr. Hamza, oh sorry, it's a technical issue. Actually, it's not my voice. Okay, so for Mr. Hamze, you said earlier that there are three at least parameters that for the electrospray to be worked, right? The first one is the flow rate, right? And then the second one is the distance of dipping, and not to mention the last one. And we know that the flow rate, it must be like not really that strong, but not really that slow, because then if it's too strong, the high voltage will not like what it's called like a stable distribute. And then for the distance, the higher, then it's not really that optimal. But then from that to those two parameters, we know that the successful of the electrospray depends mainly on the high voltage or the electrostatic force, right? Not really, but then maybe you can answer my question. The question is about to what extent actually this kind of method with regard to the stability of the API, because we use the high voltage, and maybe you can elaborate more about the limitation of the high voltage, because maybe there's some kind of related to the zeta potential, maybe not directly related to the zeta potential, but then we know that maybe there's kind of interaction between it. So I think that's my question. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for the question, Mr. Yuda from Ahmad Dahlan, University of Ahmad Dahlan in Yogyakarta. Okay, maybe Dr. Nat first gonna answer the question. Yeah, please.
And he said why BIAP2L1, the name of that gene, why important in the migration. So back to the background, no? Back to the background, and in the first a few first slide, and you know in the BiAp2L1 is amplification in the cancer cell, in the many cancer cell, and we found is 6 of gene that amplify in the cancer cell, such as CDK4 and CDK6, that now that in this group two target is became to the new medicine. We know the CDK4, CDK6 inhibitor, or we know as the palbociclib, to treatment the cancer, to proliferation of the cancer. And so BiAp2L1 is the one of this group, and I think it may be, it's likely the close friends maybe have the important same their friends. And so why I focus in the metastatic or migration, because for the primary tumor, we have the many drug or many targeted therapy to treat it. But for the the metastatic cancer, or we know it a cancer in stage 4, now we have a few drugs that can treat it, or maybe someone cannot use the drug. So why I focus on the migration of the cell or metastatic of the cancer cells. So I try to improve in many characteristics that I show in the picture. I prove in the apoptosis, uh, the but it's not significant in the that characteristics, or I prove in the many characteristics, but finally I found that the BiAp2L1 have the importance in the migration characteristics. So I too want to find that what the mechanism that can make the BiAp2L1 to promote cancer migration. So we come to my research. And finally, in vitro experimental experiment, I found the BiAp2L1 is important to increase the Philadelphia or F-actin to that have the cause to promote to the cancer migration. And I hope, like the CDK4 and CDK6, someone will pick my paper to study more or in the deep, or study in the in vivo, and to find the new drugs to treatment the migration from my target that I found.
Okay, thank you. Is it okay? Yeah, okay. We will move to the next question. Yeah, please
Okay.
answer.
First of all, thank you so much for your question. Actually, this reflect that you're really following the technology. You understand it very well. Okay, so I will try to answer. If I miss any point, just let me know to cover it. Okay, for the effect of high voltage on the formulation or the particles, actually this true can be. During the literatures, there is not that much of the studies like to cover that, but we could add one of the points at the variables or the response, the stability. We could add it during the optimization to check is there effect or not. But in my opinion, where is important or more important when we are going to the very small particles, like nanoparticles, or the small of microparticles is the lower range of microparticles. When you are going to the small particles, for nano size, is more important like to study the zeta potential of the particle to see the effect or not. And for sure, as complete a project, this is including my work or my study, I will have a stability study. I will have a stability study, maybe not during the optimization, but after I have the formulation complete. It's already done, but I didn't cover all the points here in my presentation. We have a stability study. We have to check the API. For example, in my work, we have the active ingredient of black seed oil is thymoquinone. Thymoquinone as anti-cancer, blah, 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 blah. So we done the HPLC studies to see the stability after the formulation already produced, and we already check. Actually, at this stage, maybe if we continue the stability, because we done it like for 1 month or 3 months duration, under accelerated stability study and real-time stability study, there is no effect of the high voltage. But actually, it's very good idea to include it to study like the effect, like especially for, as I mentioned, for the nanoparticles, to study the zeta potential, to see the surface charge of the particles, because it's important for suspension, for it's important like also for even for target release, also is very important. So I think for the large particles, beats like 1 millimeter or above, or 1 or to 2 millimeter, I think is not that critical, but could also we study it, but is more important for nanoparticles. For the parameters, yes, the first parameter is without high volt, there is no influence for anything. So that, but also the flow rate without the volt is very critical. Okay, let's say that we have ionic gelation method to make particles without the volt. Ignore it. We have just to make ionic gelation particles. After gelation, we collect the particles. The flow rate is very important by itself. So the main two factors is the flow rate and high voltage for the electrospray ionic gelation together. Why the flow rate? Because as you mentioned, if it's already too high, then we don't have the dripping. So there are no spherical particles. It's going to be like continuously going there. So it's going to be as line. After gelation, it's going to be as line inside. So there is no droplet. So we have to choose the critical flow rate. But including together with the high voltage is very critical, the flow rate. Because it's based on the need. Okay, for you, you are targeting to have microparticles. Like let's say that 100 micro or 200, 150. So in this case, you have immediately, we will have the target of the flow rate, you have to go to the very slow one. You shouldn't go to the high one. So it's wasting time. There is no particles in that side. So this is why you have to know the range. If you want to go to nano, that means you have to reduce the flow rate. It's very small flow, because as you mentioned, you already mentioned it, it's because when we have the flow rate, we have, you have to give enough time for the volt to influence the droplet, to let it go down. Then once you have the enough study, why I included the distance at that time, because I'm studying it for large scale. Large scale, as I mentioned, once you have a lot of particles already encapsulated in the curing bath or the calcium bath, once it's have it there, that the distance is already changed because the volume is already increased. So this is why. So how to overcome this one? As I mentioned, but this one, like you need like to design a new production line or to do it in the lab first. It's like we are studying it with the time. So this is why I included there. But for lab scale, if you are not thinking about like large scale, the most important just to choose the suitable distance, fix it, and just go ahead with the other parameters. Hopefully I didn't miss any point. Okay, that's all.
Okay, is it enough, Mr. Yuda? Okay, thank you very much, Mr. Hamis, for the discussion. And then second question, anyone? Okay, please. Please mention your name and the institution.
Okay, good morning, Dr. Nat, Dr. Hamzah, and Dr. Dian. And good morning, all of participants in this seminar. Let me introduce myself. My name is Danang Aji Wiguna. I'm from the first semester of postgrad pharmacy student in Setiabudi University. My question just simple. For the first question for Dr. Nat, you have explained about BAIP to L1 in cancer cell migration. So my question is, what are these implications of these findings of us or research for the future development of anti-cancer cell therapies on the future? Check. Okay, and for Dr. We know that implementing this technique or micro encapsulation technique in commercial scale, in industrial scale, we need an investment in a machine, in a man, like operator, and we need investment in the research too about the stability of product and the compatibility. We know that many products are using in micro encapsulation, but the price is higher than the other product. In your opinion, this technique, if we apply it in Indonesia, also of course in BPJS era, are these feasible or not? Maybe Miss Dian can explain what is BPJS era. Okay, thank you for question. Thank you.
Okay, thank you very much for the question, Mr. Danang. BPJS is kind of the health insurance from our government. So, and it's very low cost actually, low budget. Yeah. Okay. Maybe Mr. Nat wanna answer the first question.
For your question for the future of research of BIAP 3L1, in my opinion, I think in the pathway of the migration of phosphocofferin and cofferin, I think we should to study too deep in the signaling of protein that relate with this protein phosphocofferin, because I mean in cancer cell you cannot know only the target gene, but you must to know the signaling to how to promote the gene function or stop gene functions. And sometimes we have the problem when we want to find the new drug recovery, and we found if you have the some gene and this function, and between have the many protein that relate, and we call the signaling pathway. Sometimes we found that some drug we cannot block in the up downstairs, upstairs of the signaling, or some that cannot stop function in the downstairs because it affect to the normal cell too. So we think we should to want to more deep in detail in the signaling pathway of the cofferin and phosphocofferin to found its signaling pathway in clearly than now. For focus towards the protein of signaling, we can cut it off to stop the migration, not affect the normal cell too. And we want to explore in the animal model too, because we to do in only the cell line in the in vitro, and so we want to more approve this effect in the in vivo model. But in my research, when I do in the animal model, we have the stuck in some problem because the animal to reject my cancer tumor that I put in them. And but now in Thailand we have the new animal model is skid model. The rat or the mouse it no immuno. It have the immunodeficiency absolutely, no T cell and no B cell, and it have the benefit to test in the cancer from the patient put in the animal model. And I think if we have the budget, we will explain to the in the skit model.
Okay, Ina?
Okay, so now for my part. First, okay, thank you for the question and also to ask me advice or opinion. Okay, I will make it as yeah, advice and opinion. So for first, as a student, when you don't have that fund and you like to work on this technology, it's okay. No need to think about the larger scale. Just think about the lab scale. Like to achieve, like of course, always there are objectives for your research. What is your objective? Why you are doing this research? Why you have to have encapsulation for this material or that material? Like this one for the lab is not going to be so costly if you have the facilities or the equipment for analysis. Like for example, like if you have UV, HPLC, like some other equipment like for analysis, like to do release study, for example. So it's not going to be so costly. So for lab, you just enjoy the lab, enjoy the experiments you can do and test and also publish. So this for publication. Okay, so now for the advice or yeah, actually for us, how we start the idea of our work, because the culture in Malaysia and Indonesia is so far is almost like same, yeah, same belief, and also with Arab, so it's not that so much different. So as I mentioned, you have to know what is the objective of your research. It's not like, oh, I want to do, we already discussed this morning before we enter about like, okay, just to have to study or just to publish. Okay, to publish is something good, very good. Just do it aside. But also for like master project or for PhD project, it shouldn't be only for that. Should be for to achieve knowledge, to achieve, to improve something or to find something novel. So this how you should think. So okay, so for black seed oil, I will give you this example. Then you can measure on this example to understand the point. So for black seed oil, it's already available in the market, and so many they are consuming it. But there are two groups, sensitive groups. It's difficult for them to consume it because the taste is very strong, like habat sauda, you know it, correct? So the taste is very strong as oil. It has been, yes, it has so much benefits. It is confirmed with so many studies. It's not our work, it's other people's work. We saw it. So it's confirmed like that it has benefits. But I want to give it to kids to make their immune system stronger, or for elderlies. Like, but how the form available in the market or in the pharmacy shop? You can find soft gelatin capsule, which is already like large capsules. For kids 6 years old, how you can give them this soft gelatin or hard gelatin capsule? It's so difficult for them to consume, to swallow it. And for also for old people, like when they have, all of us, we have in our families like elderlies. Some of them, they already have Alzheimer's. So it's like, it's so difficult to deal with them, to give them medication, or I want them to get the benefit of this product. So for me, I give it as example, then you can measure for other products. So it's difficult to deal with, to give them or to consume it. So you have to find way. So you have to give the oil as itself. Oil as itself, first of all, the texture of oil in general, whatever the oil, is not that much easy to swallow oils. Correct? Oil is like, you have to mix with salad, you have to mix with other things to consume it. But it has also, specifically for like propolis or for black seed oil, it has very strong taste. The kids, they will never take it. You have to push them to give them the oil. You cannot. Tabuli. You cannot. Then, so you have to find way. So how to find way? You can, okay, we have microencapsulation using sodium alginate. Why? Because it's safe and it's easy to deal. It's already in the market, by the way, for other things like to be used is food grade. So in this case, you can see, okay, once I make this product and it's already in the market, for sure you will have customers that there is investment there, that they have. So this is why you have to give proposal to explain, to justify strongly, like this one is already in the market, so why not to have another product that it can improve the suitability, how to consume it. So for sure, and especially that is not in the market yet. I mean, this type of advanced product. Not, so once you have it, that means it's. So this is how we think. This is how we think that already there. This is why we got the grant from the Malaysian government. Not me, it's my supervisor, but through my results. It's like that. You always like the cooperation between the student and supervisor. So we applied for grant, and we got about, it was about 1 million ringgit for Malaysian ringgit for that project to do it. So this why? Because you already justify what you want to have. Is new technology, is nice technology. So it's like that. So you have to justify. As lab scale, you just enjoy the lab. No need to think too much above that. But if for investment, you have to justify very well. Hopefully I answer and I give the correct advice.
Okay, Mr. Dana. So the most important is knowledge first. Okay. Another question from the third participant. Anyone? I think from the center. No one? Okay. The online session? Participant joining online, is there any question from the online participant? No? You want a question? Yeah, okay.
Hello. Hello. Good morning, Dr. Nat and Dr. Hamse. My name is Nanda Putra Amata, and I'm from University Setiabudi. I'm majoring pharmacy, and I have some questions for you. For Dr. Nat is, what is considering that acting dynamic are essential in normal cells? And what is make BAP21 driven actin reminding more prominent in cancer cell compared to a normal cell? And for the Dr. Hamza, from the main effect of the interaction plots, how can we identify which parameter has the strongest influence on the drug rotation without statistical overfitting? Thank you so much.
Okay, thank you. With Miss Nanda. Yeah. Okay, Miss Nanda. Dr. Nat, can you get the question?
Okay. From your question, you want to me to explain, to compare between the F-actin or Philadelphia, I mean the Philopodia formed by AT1 compared with the normal cell. So in this information, I say I don't have the information when compared with the normal cell because I study in the cancer cell line and I put the some plasmid to force the cell have more BAP2L1 gene in cancer cell. So I can say how the different from the normal cell. That is the future research that I should to do more. But I can tell you that when we compare between the cancer cell line and the cancer cell line that I put the BiAP2L1, or we can call it the overexpression of BiAP2L1. We can say that the BiAP2L1 can promote or to have more Philadelphia or the F-actin more than the cancer cell line that not put the BiAP2L1. And so one model I use the TTT cell line, the immortalized cell line, that not cancer cell line. It's based on the last cell line, no? And I put the BiAP2L1 plasmid in TTT cell line and then induce it to, the benefit of when you use TTT cell line, immortality cell line, it the inducible system, and when you want to express some gene, you can induce it. Or when you don't have that gene, you can stop it. And I think it maybe can represent in the normal cell line in the human. So when we induce it, express of the BiAP2L1, the F-actin of Philadelphia is more than that I not induce it. So now I can say that the BiAP2L1 is a part of, is a gene that can promote the F-actin or Philadelphia. But not sure when compared with the normal cell in the human normal cell. And you have another question for me?
You have another question? One or two questions? Oh, just one.
And I can answer your question clear?
It's already clearly. Okay, thank you very much, Dr. Nat. And then the time for Dr. Hamzah to answer the question.
But the last part of your question I couldn't hear very well. You asked about how to select the parameters. For drug, I'm
the
sorry.
Strongest interaction with the
without overfeeding.
To our body.
Overfeeding.
Our
Overfeeding.
overfeeding,
Feeding.
feeding,
Yes.
curve feeding,
Overfeeding.
overfeeding. I think the curve you show it before.
Okay. So the strongest interaction. Okay. Actually, for the optimization steps, it has like, there is, first of all, is based on experience. Experience, it will play a very, very important role for that. If you don't have experience, you will learn, but you could waste time. But this why it's but as a student, yes, you have to go through it. It's okay, you have to get the experience. You have to learn here to know how to choose the parameters, this first. Then for optimization, as I mentioned, it has steps. First step, to make screening. Screening, what means screening? You have to put a lot of parameters. This parameter could affect, this parameter couldn't affect, but I don't know. I have to confirm. This parameter could has effect, but not so strong. I don't know. I have to confirm. This parameter, I'm not sure. Could affect, could not. So we have to put parameters. But you can put a lot of parameters, but you shouldn't do that. You have to put parameters that is related to your experiments. You have to put that first. Then you have to make the screening first. After screening, you have to do the main effect. There is significant effect, there is no significant effect. So how then we can confirm by the interaction effect. We have the interaction effect. Usually we have softwares like SPSS, we have Minitab. So we have the softwares that we can use to do the analysis, to do the experiments. Like we have design, we have full factorial design, we have also other designs. For me, I follow the full factorial design. So following the steps, you have to, they will guide you, okay, you have to make these experiments, number of experiments, how many times you should repeat, then you have to key in your result after you do the analysis, after you get the experiments. Then the software will do the analysis for you to show you that is it significant, not significant, to give you the results. Later on, you can confirm, then you will go for the last step, which is the surface design. That one for optimization step to get the optimized parameters. So at that stage, you can go only for the last significant parameters. No need to do for the other screening one because it's already done before. So this in general how the steps that for optimization. Of course, like you can try a lot of experiments could be not included in your study, but it will guide you where to go. And also there are other technologies to select the parameters, but maybe like the time is not that enough like to explain all. And also for me, I have to get like more knowledge about like that. But in general, there are steps you have to follow it to get the parameters. Hopefully I answer as I can your question.
Okay, thank you very much. Is it clearly enough? Yeah, it's a more technique, right? Okay. In the online Zoom, I mean in the Zoom, there is a question. Yeah, I will read the question. This is question from our student. Her name is Nadine. And she wanna ask the question to Dr. Hamzah. Okay, the question is, how does the electrodynamic behavior of polymeric solution during electrospraying influence particle monodispersity and encapsulation efficiency in ionic gelatin-based microencapsulation system?
Okay. Okay. So this is why when we have the electrospray, we have, as we mentioned, we have few parameters is going to affect it. But the first one is the high volt. So for the high volt, when we apply the high voltage on the particles, it will try with a fixed flow rate, it will try to make the size of each droplet same. Why? By the effect of the electrical fields. We have electrical fields there. This field is going to push and guide the droplet to go down to the curing bath. So by this step, we are going to have like size distribution, good size distribution, because always for particles is not enough to mention size. It's not enough. You have to mention size and size distribution. Why? Because all technologies to measure the size particles, it will give you the average of the size. Okay, we have so many like millions of particles already produced, but then we have the average size. But what about the size distribution? What the range? We could have very large particles and we have very small particles. The average is going to be at the middle. For example, just like to explain it. So, so this is why the size distribution, the range should be small, meaning that the small particles and the large particles is already close to each other. So what benefit we can get from that? We can control the dose. For example, we can control the stability of the formulation. So this is why it's important to have the size distribution right. So we have to mention two things together, the size of the particles and the size distribution. For the another point, encapsulation efficiency.
Yes, encapsulation efficiency in ionic gelatin.
Okay. Okay, so for encapsulation and efficiency for ionic gelation, also, first of all, as I mentioned in the slides, but maybe I didn't give enough time to explain it, the first good step is the mixing step, the first mixing step, plus or mixing or emulsification. It's based on the material that I want to encapsulate. Could be powder, could be oil. If oil is emulsification step. If it's small powders, it could be suspension. If it's like water soluble material, could be mixing to make a solution at the end. So the first step is very important to homogenize the mixture or the emulsion. It's very important to have that. Why? To affect the encapsulation efficiency at the end. For example, for emulsion, if the emulsion is stable, that means the oil is not going to be separated from the alginate solution during the gelation step. So this why the emulsion to be stable first is very important. The other thing is sometimes based on the formulation we could use stabilizer. When we use a stabilizer to make the mixture stable or the emulsion stable, also will avoid the leaking or the separation from the oil during the gelation process to get the particles. Another step, Ashley is going to explain, it will take a little bit long time. The other step also, for example, the size of particles. When the size of particles, large particles, it will take time to be cured with calcium ions, completely get gelation completely, fully gelated one. So that means there is taking longer time for the oil or the encapsulant that I want to encapsulate to be separated from the alginate because it's taking longer time. But if I have the small particles by the effect of alkyd spray, the small particles, because it's very small, so once it will touch the calcium chlorine path, it will start to get the calcium ions and it will get gelated very fast. So there is no time for the separation to happen. So this is why we got higher encapsulation efficiency with the smaller size, which is already produced by the high voltage. What else?
It's enough.
Oh, I
Yeah, you answer all questions. Yeah, thank you very much, Dr. Hamzah, for the answer. Okay, I'm sorry because the time is limited. We have to end this panel discussion. So thank you for your engaging question and thoughtful response from our speakers. Unfortunately, due to the time, we must conclude the discussion here. And ladies and gentlemen, please join me to giving a warm applause for the speakers for their excellent presentation and valuable contribution. Dr. Nat and Dr. Hamzah, thank you once again. You might kindly return to the seat. And then to proceed with the next agenda, I would like to return the session to the Master of Ceremony.
Thank you, Dr. Dian and our speakers for the enlightening discussion.
As a token of our appreciation, we invite the Dean of the Faculty of Pharmacy, Dr. Apotheker Iswandi Magister Pharmacy, to present certificates and of appreciation to our speakers. We will enter the third session with the same moderator, Apotheker Dian Marlina, Sarjana Farmasi, Master of Science, Magister of Science, PhD, and keynote speakers, Professor Arai Ichiro, PhD.
Dr. Dian, the floor is yours.
Okay.
Okay, hello everyone. Masih semangat? Masih. Okay, before we start with the next session, firstly, I would like to thank you for the participants who still stay in this room. Please give applause for us. Okay, thank you everyone for the applause. Now we will continue to the next part of the program, which will be conducted to online media. Okay, it is my great honor to introduce our distinguished speaker joining us virtually from Japan. Okay, our speaker will be Professor Arai Ichiro, PhD from Nihon Pharmaceutical University. And he is the Vice Rector of Nihon Pharmaceutical University. Maybe you can start with the presentation. For the third slide, there is a curriculum vitae. Okay. Is he already joining in the Zoom? Can we check,
Yes,
Professor Ichiro? Okay.
I already connected.
How can I move here? Konnichiwa, sensei.
ありがとうございます。ありがとうございます。
こんにちは。お元気ですか？
お元気です。
Can you hear me clearly, Professor?
Yes, I can see you clearly.
Okay. We are here really honored to have you with us today. So, Professor Arai is widely recognized for his contribution to natural product research and for bridging traditional medicine to modern pharmaceutical science. Japan has long been respected for its strong scientific discipline and innovation, and we are delighted to learn from Professor Arai's expertise. Okay, Professor, you will have 45 minutes presentation.
Yeah.
If you can hear us clearly here, please confirm and you can start the presentation.
Thank you very much. Hello, everyone. Hello, not hello. I'm the Ichiro Arai of the Nihon Pharmaceutical University. I have held the last August. I held the conference of Asian Association of School of Pharmacy. At the time, many friends of Indonesia have come to my university. At the time, our university we made the Memory of Understanding about the collaboration with the Association of Indonesian Pharmacy Higher Education, including University Setia Budi. So at now, my university and your university is the friend. So every August, we had the summer program in my university, educating the Japanese pharmacy and the Japanese culture. So if you have a chance, please, the next August, please come to my university and learn together. From now, I talk about this theme, advancing natural product research from traditional medicine to modern medicine. In the screen, my photo in the screen is the black hair, but at now my hair is completely white. And my picture in the screen is that in 10 years ago. So before the corona pandemic, during the corona pandemic, I stopped the hair dyeing. So the real color of my hair is white. So let's start. Please, the next slide, please. Next slide, please. It's the short, my career. This showed my career. And I'm the dean of the vice president of the Nihon Pharmaceutical University. But I have worked for a long time in the Japan Society of Oriental Medicine as a member of the committee for EBM.
Hello?
Okay? Hi. My major, one of the major. Oh, sorry. One of my major is the EBM. Do you know EBM, evidence-based medicine? EBM in the traditional medicine field. And the next my major is standardization of the crude raw materials. I work about 15 years in the International Organization for Standardization. We have made over the 100 international standard about the traditional Chinese medicine, herbal medicine. And also I sometimes work in the WHO for the strategy of the herbal medicine. Next, please.
Next, please.
Next, please. If you interest my career, please take a photo in this QR code. You may understand my whole career and recent work. Next, please. Today's my lecture is on the development of traditional herbal products as medicines. In Japan, the medicines and food is separated. The regulation of the medicine and the regulation of the food is completely separated. I don't know the situation in Indonesia. Today's my lecture is about as the medicines, but maybe it can be applied for the herbal health food. Next, please. Next, please. I know the jamu, the traditional Indonesian medicine in Indonesia. So I don't know the present situation of jamu in Indonesia, but Indonesia is the warm tropical island. Many plant, many herb develop. So there's a good source for the medicine. So jamu may be the one of the good resource of the new medicines. I think so. Next, please. There's a three type of medicines medicinal product development from the herbal materials. First is a pure compound from herbal materials. It is a very popular developmental way of the new medicines. The second is the crude preparation from herbal materials. Second one is the different from the first one because the first one is a pure compound. Second one is a crude one, mixture of the several ingredients. And the third is the crude preparation from herbal medicine, traditional usage. Today's my theme. I talk in this third section. Traditional, the herbs, people use for a long time, but it is the not still medicine. So today's my lecture is how to develop the new herbal materials from the traditional ones. Next one, please. This is an example of the first one, pure compound from the herbal materials. This slide shows the general way from the herb to the single compound medicinal product. You know the oseltamivir. It is the anti-influenza virus drug. It is very famous in Japan. So, but indeed, this is the first discovered in the natural product. But in general, natural product is potential is not high. So generally, synthesize from the lead compound of the natural product, the synthesize the new product that is more safe and more potential. So at last, this oseltamivir is developed as the anti-influenza virus drug. But this is not traditional medicine. This is a modern chemical medicine from the herbal product. Please, next slide, please. This is the second example. Do you know the ginkgo biloba? Ginkgo biloba is the symbol of the Tokyo metropolitan city. It is very popular plant in Japan. Recently, the extract of this ginkgo biloba leaf had a potential to the dementia. So in Germany, the active fraction mixture of the several ingredients was developed as the drug for dementia. It is now the sold in the EU market, but it is the new discovered usage, not the traditional usage. So next, please. My major is traditional medicine. In Japan, it's called Kampo. It is derived from the ancient Chinese medicine, but at present, the Japanese traditional medicine Kampo is not same as the present traditional Chinese medicine. But in Japan, the extract of the Kampo medicine is broadly used in the Japanese medical systems with the new modern medicine, new modern technique. In China or in Korea, the traditional medicine and modern medicine is completely separated because in Korea and in Taiwan, Korea, the license for the traditional medicine have present. But in Japan, there's no license only for traditional medicine. The professional medical doctors who have the license of the doctors who use the modern Western medicine and also this type of the traditional medicine. It is the characteristic of the Japanese medical systems. Today's my topic is to develop this type of the medicine. Next, please. Right. Traditional herbal medicine. How are they different from the conventional modern medicines? Next, please. Next. Requirement for the conventional modern medicine is, of course, have the consistent quality. Generally, the low molecular, the Western medicine is a one compound. So the purity is very important. So of course, the constant quality is assured of the purity. And second one, the clinical efficacy and safety. You know, this 2 point is important in the conventional modern medicines, modern product. Next, please. But traditional herbal medicine is crude substances, mixture of the many kind of ingredient, not a single compound. So it is hard to control the quality of this mixture. Next characteristics of this traditional herbal medicine is the few clinical data. Many people say traditional medicine have a long history. Then, because the traditional medicine have the long history, that it is believable. It have the no side effect. It's not real. Long history is not same as the efficacy and safety. It is different. Long history is not approve the efficacy of the safety of the product. Next, please. Next slide, please. What shall we do to develop traditional herbal medicine as scientific modern medicine? Why is the CMC side, chemistry manufacturing control? It is a quality, how to assure the quality. The second one, the right side, right one is efficacy and safety. In general, to develop the new modern medicine is the preclinical test, in vitro and in vivo. And next, the clinical studies, phase 1, phase 2, 3. Finally, generally, a double-blind control, randomized control study was performed to develop the modern Western medicine. Is it need for the, or even for the modern, even for the traditional medicines? Next, please. First, I talk about the quality assurance of the herbal medicines. Next, please. Major characteristics of traditional herbal medicine is crude substance, as I said before. Crude substances means contained many ingredients, many active ingredients, not a single compound. Next is not all active ingredients have been identified. We can catch the product ingredient the highly included in the herbs, but there's many minor compounds in the herbs. We cannot know the whole the structure of these compounds. And third one is that not all metabolites have been identified, so it is difficult to the measure of the blood concentration of these all metabolites. And fourth is the ingredient content is not consistent. It is the most important point to develop the crude substance. crude substance, natural herb is agriculture product. The quality is not always consistent. But what we will do in these crude substances? Next, please. Next slide, please. Many researchers focus on the efficacy of the herbal product. But in the base of efficacy and also the safety of the final product is the quality of the product. Some researchers write the papers of the pharmacological action of the herbal medicine, but there's no assurance the herbal materials they used in the experiment. So first, before we check the efficacy and safety of the herbal product, first we make the quality control of the herbal product. So the quality of the raw materials, quality of the final product is the most important thing to research and develop of the herbal product. Next, please. Right. This is the 3D HPLC fingerprint, generally called the chemical fingerprint. The left side is the chemical fingerprint of the aspirin. You know, aspirin is one single compound, so the peak is only one. But the right one is the Kakonto. It is the most famous Japanese herbal medicine. You can see the many peaks, many peaks. So aspirin and the herbal medicine is completely different in the contents of the ingredient. But we must control this herbal product. Next, please. Next one, please. Constant quality assure the reproducibility of the efficacy and so forth. So we can check the efficacy. Before we can check the efficacy, first we must assure the constant quality. It is the most important thing to develop the herbal product. Next, please. Next, please. Is the steps to make the herbal product from the plants. The upper one is the herbal plants. To assure the quality of the herbal final product, use herbs and plant with consistent quality. We generally use to this purpose. We use GACP. GACP I will explain after. So next step, second is raw materials. Generally use this type of materials, dried ones of the herbs. So at this stage, we must check the quality again. And from the raw materials, we make the constant manufacturing. You know, the step is the GMP, good manufacturing product. And finally, we make the final product. And we again, we check the quality of this final product. From the beginning of these steps, halves, the four times, we check the quality of the product. It is very complicated. And next, please. How to define the herbal species? the most important thing, a basic thing, is the defined Haber species. It's called identification. Next slide, please. Generally, we define the Haber materials is the scientific name of species. It's called Latin name and medicinal product. It is we must before we define the herbal materials, we check the scientific name, Latin name, and part of the plant, part of the herbs. Next, please. Next slide, please. These three herbs. The top one is Uncaria lyncophylla. Second one is Uncaria sinensis. The lower one is Uncaria macrophylla. It is a very similar kind, similar species. But this chemical fingerprint is quite different. So we should not mix these three herbs. We check which species, Uncaria lyncophylla, Uncaria sinensis, Uncaria macrophylla. First one is we distinguish the species of the similar plant. Next, please. So the first step is the identification is the visual appearance, you know. The very if we can distinguish by the visual appearance, it is very easy to distinguish the herbs. But sometimes it is very similar visual appearance herbs. It is difficult only by this technique. Next, please. So if we cannot distinguish only by the visual appearance, we also the microscopic appearance of the herbs. Next, please. Recently, the genomic identification is popular in this area. So we cannot distinguish, identify by the visual appearance and microscopic appearance. We use the genomic identification. Recently, this is very popular in this area, recently. Next one, please. If the herbal species was defined, the quality is not always identical. It is a very important, very difficult point. Next, please. The left fingerprint herbs. The right one is both is the chemical fingerprint of the same herbs called the Uncaria lyncophylla. But chemical fingerprint is quite different, left one, right one, because there is different harvest ground. So the quality of the herbs is chemical harvest ground and the condition of the harvest ground, and also the climate and the weather affect the quality of the herbs. So from this point, make it's two difference to control the quality assurance of the herbal medicines. Next, please. And another problem is wild and cultivar. The three types of the tomato have the same scientific name. So we only check the scientific name. These three types of the tomato have the same quality. But you know, the sweetness of these each tomatoes is quite different. So this shows that it is difficult to assure the quality only by the scientific name. So we must use the constant cultivar to make the constant quality herbal product. Next slide, please. And also harvesting time is also affect the quality of the herbal product. This figure shows the content of aconitin alkaloid of the aconite tuber. Aconite tuber is a very toxic compound. So in the autumn, the content of the aconite alkaloid increase. So if you get in this herbs in the springtime or autumn time, the quality of the quite different. So to make the constant quality, to make the herbal product is constant quality, is to harvest the same seasons. Next, please. And the processing is another problem. In East Asia, some raw materials the use after the processing. In this slide, show the processing of ginger. Ginger is maybe the famous also in Asia. In Japan, we use ginger, dried ginger. It contains the 6 ginger roll, left one. But sometimes we Japanese use this ginger after steaming. After steaming, the 6 ginger oil changed to 6 sugar oil. The characteristics of these two compounds is quite different. So according to the purpose, we use the ginger or the processed ginger. Next one, please. Next one, please. Herbal medicine is a medicine, but indeed it's agriculture product. So agricultural condition affect the quality of the herbal product. Next, please. You know the GAP. GAP is a good agricultural practice. This means in agriculture steps for the herbal medicines, the constant agriculture method must be used. Next, please. And still now, some herbal raw materials is the cultivated one, but still some herbal products is collective ones. So the combined agriculture and collection. This is a GACP, Good Agriculture and Collection Practice. WHO published the guidelines for this GACP for medicinal plant. You can get this book freely from the WHO website. If you want to develop the constant quality herbal product, you should read this book. Next one, please. Hi. In Japanese pharmacopoeia, the many herbal products were listed. In each monograph of the raw materials, these items was defined. First is species, origins. It is a Latin name, a scientific name of the plant. Then next is a medicinal part and processing method, and visual appearance, microscopic appearance, as I said before, color, odor, taste, and the marker compounds and their relation. It is a most important thing. And next is the chemical identification method, purity, foreign matters, heavy metals, arsenic, residual pesticide, loss of drying, total acetone. This is the we must assure in these items to develop the herbal product. Next, please. Next one, please. Okay. The upper one is glycyrrhiza. It is very famous in East Asia, China, Korea, Taiwan, Japan. It contains the glycyrrhizic acid. This compound has many effects to humans. But in Japanese pharmacopoeia, glycyrrhizic acid is not less than 2.0%. This is the one of the marker compound. This is a marker compound of glycyrrhizic. The next is a Scurataria radix. In this, the herbs, we set the bicarbene not less than 10% as the marker compound. Like this, the many marker compounds were set in each medicinal herbs. And after we assure the quality of the raw materials, next we make the manufacturing. At this stage, the constant manufacturing is very important. Next, please. Like, you know the GMP. GMP is the good manufacturing practice. To make the good quality medicinal drugs, medicinal medicine, we must secure the pharmaceutical GMPs. But this GMP was set to considering only the Western medicine, single many people the crude herbal substance. So in Japan, we make the Campo GMP. This is a self-imposed standard for manufacturers. In Korea and China, this type of the herbal GMP was set to develop, to manufacture the herbal product. Recently, also in Japan, we must secure the GMP to manufacture the health product from the herbs. It is not problem only in the medicine, but also recently in the problem of the health food. Next, please. Next one, please. Right. The marker compound is important, but it is impossible absolutely uniformity cannot be achieved in the herbal product. So a certain level of the variance in ingredient contents should be accepted. So marker compounds generally express as the range of the marker compounds. Like this slide, the right one, in the final product, glyceric acid, milligram per gram to milligram per gram. It is set the lower limit and upper limit. Completely the same the contents of this glyceric acid in the product is impossible. So we control in the as a range lower limit and upper limit. This is the very popular in this area, in this herbal medicine area. Next one, please. So if we use this slide show the three marker compound, ephedrine, glycerin, pyrifluorine. We can, in Japanese, can make the many lot of the final product with the range of this area. The 100% is the center value. You can see the top range and the lower range is maybe the plus minus 20%. It is very good product. Next, please. But if we make the final extract product, it is impossible to the lot constancy. In general, we are mixing of the multiple lot to constant quality. The left one, the instant coffee. Instant coffee is the same brand. Instant coffee is always the same taste. Why? The reason why the same taste is mix the several lot of the coffee beans. And also another problem, other examples. Beer. Beer is the agriculture product. But same brand beer is always the same taste. Why the reason the same taste is mixing the beer company mix the multiple lot of the raw material, raw herbs. Like this, in the herbal medicines, we mix the several lot of the raw materials and make the constant quality final product. Right. Next, please. So we hurry. Next, please. Next one, please. Next one. Another characteristic of the traditional herbal medicine is empirical substance for medicinal purposes. Next one, please. As I said before, there is a long history to human takes. It's not approved, it's not assured the efficacy of the safety. Long history is not adequate clinical evidences. 30 years ago in Japan, the very famous traditional Chinese medicine, the person who take this traditional Chinese medicine, over the 30 persons died. But this formulation, this product, these drugs have been used for over the 1,000 years in Japanese. We cannot catch the adverse drug reaction of this product. Even we use this formulation for 1,000 years ago, 1,000 years. So next, please. So this type of the herbal medicine, in my opinion, we cannot need, the animal study does not need. In modern medicines, the first we screening in the cells, enzyme cells or the animals. But in the traditional medicines, the humans already take this medicine. So in the steps to develop the new medicines, we can skip this animal stage. Next one, please. In the clinical stage, in the modern medicines, we must the research in the phase 1 clinical study, phase 2, phase 3, because the compound have not taken in human. So the safety of this compound is not assured. But in traditional medicines, the medicines have the experience to take by human for some period. So we can skip phase 1 or phase 1 or phase 2 or all the clinical trials we can skip according to the evidence of the long history. Next, please. Hi, this is conclusion. If there is a sufficient history of use in human, the early stage of clinical studies may be skipped. Animal tests have little significance in the development of traditional medicines. For clinical studies, test drug with standardized quality must be used. Next, please. At last, I refer the unwanted compound in herbal medicines. Next one, please. Unwanted compound in herbal medicine is this type of the problems. The most famous one is the residual pesticide. The cultivated raw materials is generally pesticides is used. So the residual, we must check the residual pesticide in the raw material stage and the final product stage. And the second problem is heavy metals and arsenic. There's heavy metals in the soil in some area. So it is very toxic. So we must check the heavy metals and arsenic in the raw materials and the final product. And the microorganisms and the fumigants and the mycotoxin. These are the other problems for the herbal product. Next one, please. In this area, WHO also make the guidelines. WHO guidelines for assurance quality of the herbal medicines with reference to contaminants and residues. You can get this book from the WHO homepage freely. If you're interested in the development of herbal product, you should read these guidelines. Next one, please. But there's many kind of the pesticide is used for the cultivation of the herbal product. So it is impossible to check all the pesticide. So recently, we assure this by this traceability system, we assure the quality of the herbal materials. Someone buy the raw materials in the market. They don't know where this house was cultivated. It is very dangerous. So recently, we must check in the far cultivated places and check which pesticide was used. So we must check the used pesticide is a good way to assure the final harvest product. Next one, please. That's all. Terima kasih.
Okay, thank you very much, Professor Arai. Arigatou gozaimasu,
ありがとうござい
Sensei.
ます。はい。
I, okay.
ちょっと長く
Your
なってすみま
explanation.
せん。長くなってすみません。
いえいえいえ、大丈夫ですよ。Okay. Sensei, your explanation on the advancement of natural product research and its transformation from traditional in medicine into modern therapeutic has provided us with valuable perspective for future pharmacy innovation. Okay, ladies and gentlemen, we will now move to the question answer session. So everyone here, please, if you have any question, please raise your hand and mention the name and also the institution. Don't forget, because here the committee have a lot of door prize here, so don't afraid to ask any question. Okay? From the left side, please. The microphone, please. The left side.
Check, check, check. Check. Check.
Technician, please help with the microphone.
Check. 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 Okay. Thank you very much, Professor, for the very insightful presentation. So, I'm Yemima Aurelia from Universitas Tiabudi. As we know, Indonesia is an archipelagic country consisting of more than 17,000 islands with extremely rich biodiversity and natural products. At Universitas Tiabudi, natural product research has become a strong trend, and many pharmacy students choose herbal materials as their research focus. However, in your presentation, you mentioned the important distinction between have been used in human for a long time and adequate clinical evidence. I think this point is very crucial for us, especially for pharmacy students who are working on natural product research. But sometimes, because herbal medicine have long traditional use, they are perceived as automatically safe and effective product. But from your explanation, we understand that empirical use is not the same as scientific validated evidence. So my question is, could you please elaborate more on how we, as young researchers in natural product research, should position ourselves between traditional empirical use and the need for scientific validation, and what mindset should we build to ensure that we don't underestimate herbal medicine as a simple materials, but instead treat them with the same scientific as a modern pharmaceutical product. So that's enough from me. Thank you, Professor.
Thank you very much for the question. Sensei?
Hi.
Could you get the question? Is it clear enough? Hi, okay. Thank you. So please answer. Yes.
There's a many kind of the house in Asia. and in the world. In some herbs, many person takes every day for a long time. But another herb, only the local area the persons use. The evidence of the both is the empirical medicine, empirical drugs, but it's actually the very different. So first you distinguish the how many persons use this herbal medicine for a long time. So if you understand the persons and the evidence is enough, you can skip the early stage for the development of the herbal medicine, develop of the medicines. But if in many times it is not the decade, the history is long, but only the only the few persons take this herbs. If you understand, you must start from the animal study. But the correct if the population is over this size, you can skip. But under this population, you must from the animal study. There's no decided the point. So the first point you should do is research in this area to hear any persons in this area, what the efficacy, what the safety, and the according from this evidence, you can first in the research room, you can check maybe in the animal study, and go back to the field or the local area, and go and back, go and back. And the good answer, I have not good answer. So, but take care, care, especially in the safety, not efficacy. Safety is very important to develop the herbal medicine. It's my suggestion. Thank you very much.
Okay, thank you very much, Professor, for the answer. So, right, because in the Faculty of Pharmacy, Universitas Setiabudi, we are also focused in the traditional medicine. So that's very important insight for you, Professor. Thank you very much. So before we conduct many researches, it's more important to do the safety first. Okay, thank you very much. This is a very warm discussion, but unfortunately, because the time is limited, we have, yeah.
Sorry, I have
Yes?
one more suggestion. In the beginning of this the lecture, I introduced the three types of the medicine from the
Yes.
herbal materials. The many researcher, I'm originally the pharmaceutical researcher, the pharmacology researchers.
Okay.
So many persons use the first way. First, the pure compound extract from the plant, extract from the herbs, a pure compound, and we catch the pure compound and have the animal study. But it is very easy. But in many times, the efficacy of the single compound of the herb is very weak. So there's the possibility from the herbal pure compound to develop the new modern medicine. It is very difficult. So the second way is that many researchers can use this second way from the mixture make in the mixture the medicine the we use. So it is a little different in the quality control, but it is maybe the similar in the efficacy in the field and the safety in the field. So I hope some researcher use this type 2 medicine develop. Thank you.
Yeah, thank you very much, Sensei. Okay, Pak Dekan, maybe we have to invite Professor to come here someday because he has a lot of insight for us. Okay, once again, all participants, please give a warm applause for Professor Arai from Nihon University of Japan. Okay, distinguished speakers, colleagues, and dear participants, as we come to the end of today's session, I would like to express our sincere gratitude to all of our distinguished speakers for their valuable knowledge and contribution. We deeply appreciate the participation of our international speaker and partners from Thailand, Malaysia, and Japan, whose presence has strengthened academic collaboration and global exchange in pharmaceutical and health sciences. Today's discussion have covered molecular research, pharmaceutical technology, and natural product development, reflecting the interdisciplinary spirit of this conference and its contribution to advancing pharmacy practice and innovation. To all participants, especially our students, thank you for your enthusiasm and active participation during this session. I would like to thank everyone for being part of the second Setiabudi International Conference on Pharmaceutical and Health. May today's knowledge inspire future research, collaboration, and innovation. I will now return the session to the Master of Ceremony. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Dian and our speakers for the enlightening discussion.
As a token of our appreciation, we invite the Dean of the Faculty of Pharmacy, Dr. Apotheker Iswandi, Magister Pharmacy, to present certificate of appreciation to our speaker.
Hello, Professor Ichiro. Hello, Professor Ichiro. You remember for the photograph? The last year, the Augustus, I will come to your campus. Maybe next time I want to come to my campus. I believe you must come to my campus, Pharmacy Setiabudi. Okay, Professor. You like Professor? Bisa? Bisakah 3 profesornya? Okay, Professor. Hello, Professor. How are you? So long I was trying to find you. The last year we meet to your Nihon University. I believe, I promise next time I want to come, Professor Ichiro come to Setiabudi. Okay, the behalf of from my committee, the security, this is my certificate for thank you for Professor Ichiro have to give information, the material, but for you. This is a certificate since ceremonial. Okay, thank you very much. See you again. I can the next time you contact you.
Ladies and gentlemen, we would like to express our deepest gratitude again to our sponsor, Tisan, Sehat Bersama Sentosa, and PT Grid Mataram for your support to the second SBI CPH.
Ladies and gentlemen, we have received the midday break.
May I have your attention, please? I have an important announcement regarding lunch and the next session.
Mohon perhatiannya, saya memiliki pengumuman penting terkait makan siang dan sesi berikutnya.
For poster presenter second session, before heading for lunch, we kindly ask you to proceed to break rooms 1, 2, and 3 on the first floor to conduct your presentation first.
Bagi para peserta presenter poster sesi kedua, sebelum menikmati makan siang, kami mohon untuk menuju ke ruang break room 1, 2, dan 3 yang terletak di lantai 1 untuk melakukan presentasi poster terlebih dahulu.
We also have a special announcement. Award will be given to the best questioners. So, don't forget to come back promptly after lunch.
Kami juga punya pengumuman menarik, akan ada hadiah yang bagi penanya terbaik. Jadi jangan lupa untuk segera kembali setelah makan siang.
Additionally, a friendly reminder that all participants required to sign the second attendance sheet after the oral presentation second session. So please stay until the event is over.
Selain itu, kami ingatkan kembali bahwa seluruh peserta diwajibkan untuk menandatangani daftar kehadiran kedua setelah presentasi oral sesi kedua. Jadi mohon tetap bertahan sampai acara selesai.
Lunch is served for our in-person participants at the designated area. For general participants, refreshments are on the second floor, while for oral and poster presenters, lunch served in the first floor. And for the oral and poster presenter on the break room area, 1, 2, and 3, the lunch will be served in Sukoharjo rooms.
For our virtual participant, we will resume precisely at 1 p.m. Poster presentation second session will take place at the same time.
Thank you and enjoy your lunch. Jangan lupa untuk mengisi kuesioner pada pembicara ketiga kita.